All right, my friends, welcome back. This is going to be part 11 of my presentation on the microscopic world. And in this one here, excuse me, we are going to talk about red blood cells. Red blood cells. Now, if you'll notice in the Bible, it has something to say about it, about blood in general. In Leviticus 17, 13 through 14, it says, "And whatsoever man there be of the children of Israel, or of the strangers that sojourn among you, which hunteth and catcheth any beast or fowl that may be eaten, he shall even pour out the blood thereof, and cover it with dust. For it is the life of all flesh. The blood of it is for the life thereof." Notice that. The blood of it is for the life thereof. So it's telling you blood has a purpose. "Therefore I said unto the children of Israel, ye shall eat the blood of no manner of flesh, for the life of all flesh is the blood thereof. Whosoever eateth it shall be cut off." Now, they were not to consume blood for nourishment. Okay? That's what they're saying. And so now, and of course, it's given the hygienic part of it when it says, when you pour out the blood, you're to cover it with dust, because it's going to rot, it's going to stink, it's going to cause, all types of trouble and stuff like that. But he says there in verse 14, the blood of it is for the life thereof. It says there, the blood of it is for the life thereof. So there, it has a purpose for it. Now, it's interesting when you go back in history about bloodletting. Bloodletting, it was used until the mid-1800s for just about every disease, guys. When you look back what people used to believe, it's so wild. It's so wild. And some of it is not really that far from where we are now. It says here, one British medical text recommended bloodletting for acne. That right there just gets me. For acne, asthma, cancer, cholera, coma, convulsions, diabetes, epilepsy, gangrene, gout, herpes, indigestion, insanity. Get that, insanity, jaundice, leprosy. This next one here is a tough one. It's ophthalmia. I have no clue if I'm pronouncing that one right at all. But that ophthalmia, which is an eye infection. It's an eye infection is what that is. Plague, pneumonia, scurvy, smallpox, stroke, tetanus, tuberculosis, most forms of hemorrhaging, such as a nosebleed, get that, before surgery or on the onset of childbirth, and some 100 other diseases. Blood was removed to prevent inflammation. Before amputation, it was customary to remove a quantity of blood equal to the amount believed to circulate in the limb that was to be removed. It was tough times back then. You don't want to go to the doctor then. George Washington asked to be bled heavily after he developed a throat infection from weather exposure. Almost 4 pounds of blood was withdrawn prior to his death from a throat infection in 1799. And in the Bible, it tells them that the blood is the life. There's a purpose for it. The life of the flesh is in the blood. There's about 1 to 2 gallons of blood in the average adult. That's a little extra note down there on the bottom. Now, at a barbershop, if you'll notice that little pole up there, that was for bloodletting, believe it or not. Though recommended by doctors, barbers also did bloodletting. And you notice this barbershop pole, the red is for the blood drawn. The whole pole there, if you'll notice it, was actually a tourniquet The white, excuse me, I'm sorry. The white there is for the tourniquet that was used, and the whole pole there, if you'll notice it, it was the stick that was squeezed in the patient's hand to dilate the veins. So every time you see that pole on a barber shop, you'll know now what it was used for. Now, what's really wild is that this one has blue. So I can only assume that it was because of Blue Cross Blue Shield that you would need if you did that today. So, but at any rate, this is some functions of blood: circulation of white blood cells and detection of foreign materials by antibodies, providing oxygen and removing carbon dioxide and waste products, carrying essential vitamins and minerals. Blood has to be the right temperature and pressure and regulates core body temperature, thermoregulation. It carries regular messages between organs through messengers called hormones, and which is also known as protein hormones. Protein hormones. Now, red blood cells have no nucleus. They don't have a nucleus. Red blood cells are 6 to 8 micrometers in diameter and 2 micrometers thick. Capillaries, which are tiny blood vessels, are so small that red blood cells have to squeeze through. A nucleus, being about 6 micrometers, could get stuck and block circulation. The collapsed center is perfect for carrying and delivering of oxygen, picking up carbon dioxide. It also maximizes the amount of hemoglobin, which carries the oxygen, that can be put into the cell. It would be like the same truck that picks up your garbage from your house also delivers unpackaged food to your house, all done with no contamination. Each trip around the body takes 23 seconds, passing through the heart about 14,000 times per day, traveling some 300 miles during its lifespan, which is about 4 months, and are produced at a rate of 2 to 3 million per second. Per second. Most blood vessels in our body are microscopic capillaries. If the blood vessels in our body were laid end to end, they would be about 100,000 miles long, long enough to encircle the earth, to circle the earth at the equator about 4 times. Now, let's talk about blood clotting. Let's talk about blood clotting. Now, if you guys have ever heard of the Rube Goldberg machine, if you notice this guy over to the right there talking to this young lady, and he's got this contraption to scratch a mosquito bite. And he calls it the mosquito bite scratcher. And notice how each little thing, you've seen these on cartoons. If you've ever played that one game board called Mousetrap, each little thing falls into a next thing. It has like a domino effect. Well, that's what happens with blood clotting also. It's the same type of idea here. And so now, when we were talking about proteins, we're talking about fibrinogen. Now, if you notice that first part of fibrinogen, it's fibers. Is blood plasma protein responsible for blood clotting? Blood clotting makes up about 2 to 3% of blood protein. Now, going on, fibrinogen is a composite of 6 protein chains containing twin pairs of 3 different proteins. Electron microscopy has shown that fibrinogen is a rod-shaped molecule with 2 round bumps on each end of the rod and a single round bump in the middle. So fibrinogen resembles a set of barbells with an extra set of weights in the middle of the bar. So what you have here is you've got, let's just say all of a sudden a cut happens. And now the body is now starting to bleed out. Well, the brain says, we need to start working on this. So what happens is thrombin comes down, and let's just say that's a saw. And it comes down and it nicks the edges of what is called fibrin. And it nicks that, it makes sticky areas. Sticky areas are now created. Now, others are able to come across and they start sticking to each other. And all of a sudden, you get this chain reaction starts to happen. And each one of them start making this mesh. It starts making a mesh layer, like a net. One after another, they just start sticking to each other over and over and over again. And it keeps coming together and getting bigger and bigger and bigger. Now, these things are happening one after another. I mean, it's happening this is happening really fast, really fast. Now, what happens here is you get these red blood cells that start getting trapped. They start getting trapped inside of this mesh. And this right here is a picture of a blood cell caught in fibrin protein meshwork of a clot. That's what happens. And so the clot is formed and the healing can start to begin. All right, let's stop right there. When we come back, we're going to talk about the placenta, and we're also going to talk about the blood of Jesus, And so just how unique was it? And so, but you guys take care. I love you. We'll talk to you next time. Bye-bye.